Hello students, in this problem there are four concentric conducting shells of given radii and the shell 1 has initial charge of 10 microcoulomb and shell 3 has charge of minus 20 microcoulomb. If now the shells 1 and 4 are connected by a conducting wire, we have to find the final potential of shell number 2. So as per the condition given to us in the problem, we have four shells. Radius are given to us as 1, 2, 3 and 4 centimeter. Now it is given that initially, okay, so let us write the values over here first. R1 is equal to 1 centimeter. Value of R1 was given to us as 1 centimeter. Similarly, R2 was 2 centimeter. R3 3 centimeter. R4 was 4 centimeter. Further, the initial charge on Q1, the first shell, was given to us as 10 and Q3 was given to us as minus 20 microcoulomb. So this was the initial configuration, and initially Q2 and Q4 were 0. Now it is given that shell number 1 is connected to shell number 4, so there will be redistribution of charge. So from here I can write, let us assume the final charges to be equal to Q1, Q2, Q3 and Q4. After connecting points 1 and 4, I am assuming the final charges on all these four spherical shells to be Q1, Q2, Q3 and Q4. Now the value of V1 can be written as K Q1 by R plus K Q3 by R3 plus K Q4 by R4. Actually this follows from the fact that the value of Q2 will be 0 since the shell number 2 is isolated and it was having initially 0 charge, so we can say that the final charge on shell Q2 will again be 0. On the similar grounds, we can say that shell Q3 is also isolated and hence the final value of Q3 should be equal to the initial value of Q3, which was mentioned to us in the problem as minus 20 microcoulomb. Further, the potential of point 4 can be written as V4, that is equal to K Q1 plus Q3 plus Q4 whole divided by R4. Now as points 1 and 4 are connected by a conducting wire, we can say that V1 is equal to V4. So from here we get Q1 by R1 plus Q3 by R3 should be equal to Q1 by R4 plus Q3 by R4. Further, the equation of charge conservation suggests that the value of Q1 will be equal to Q1 plus Q4 since initially only the first sphere was having charge and fourth sphere was neutral, so we can write the value of Q1 plus Q4 will be equal to final charges on sphere 1 and 4. So now we have these four equations and we can solve these equations in order to find the values of Q1 and Q4. So value of Q1 and Q4 can be calculated from these equations. Now finally the potential of second sphere will be equal to K Q1 by R2 plus K Q2 by R2 plus K Q4 by R4. Now substituting all the values of Q1, Q2, Q4 and the radius given to us in the problem, we finally get the value of V2, which on calculation comes out to be equal to minus 32.5 into 10 to the power of 5 volt, which is our desired result. Thank you.